Welcome friends. In our last video I said that in this video we will prove some laws of set of algebra. So there are some laws: associative law, distributive law and De Morgan law. You can easily prove them using Venn diagram, but in your exams you need to prove them in algebraic manner. So to prove them by algebraic manner you need to know the definition of the equality of two states, when the two sets will be equal. Equality of two sets. Two sets are said to be equal when A and B, consider A and B two set, when A subset of B and B subset of A. These two will imply that the set A is equals to the set B. If these two things occur simultaneously, then we say that the two sets are equal. Now to prove first that A is a subset of B, we have to progress in this manner. We first have to take an element X, suppose, which belongs to the set A, and by some condition or some algebraic manner we continue this process, and if we can show that X belongs to A actually implies X belongs to B, then we will say A belongs to A is a subset of B. Likewise, we will take another element Y, which is taken from Y, which is taken from B, and some algebraic procedure. If we can show Y belongs to the set A, then we can say B is subset of A, and these two things will declare that the two sets are equal. This method is going to be performed as there are two sets are equal here. So let us prove the first associative law by the equality of two sets. We will prove now A union B union C equals to A union B union C. Another important thing I would like to mention: suppose X belongs to the set A union B. In the next line we will write that X belongs to A or X belongs to B. In our last video we saw how element taken from A union B either can be taken from A or can be taken from B. So here you use OR. Now OR is not a mathematical expression. We need to use the mathematical expression. We will write in the when we will prove that X belongs to A or X belongs to B. This is actually the symbol of OR. Okay, and when X belongs to A intersection B, we will write X belongs to A and X belongs to B. Now A intersection B is the common part of the two sets. If we take an element X from that part, then X is also belongs to the set A and also belongs to the set B. So we write here AND. Okay. Now let us prove the first one. Firstly, you write, let us consider an element X from the set A union B union C. Then X belongs to A union B union C, right? Now here is union. For union we will write the V symbol, which actually means OR. X belongs to A or X belongs to B union C. Now X belongs to A or X belongs to Now this first bracket will come here, x belongs to B or x belongs to C. Now we will interchange the first bracket. We will take the first bracket from here, from the first and to the set B, and we will write it singly. Take x belongs to as common, then we will left with A union B. When you actually take x belongs to out of the first bracket, then you will have to return the symbol to the set form, because A or B is not a set, so we have to give it a union, so we can't write or here, right? Now again, when we are taking x belongs to out, then we have to write A union B. Here this or symbol will be replaced by union and C. Now we have considered x belongs to the set A union B union C, and now we get x belongs to A union B union C. So we can say A union B union C is a subset or proper subset. You can write it also, A union B union C. Okay, this is number 1. Again, we consider an element y from the set A union B union C. So we can write same procedure, we will continue. Y belongs to A union B. This union will be replaced by the or y belongs to C. Now when y belongs to enter in the bracket, it will give like this. Just we seen here. Now bracket will interchange. Okay. We will out y belongs to from the bracket, then we are left with B union C, and lastly we out y belongs to A union B union C. Starting from y belongs to A union B union C, we have come here, so we can say A union B union C subset of A union B union C. Give it number 2. By the definition of equality of two sets, we can say from 1 and 2, we can say A union B union C equals to A union B union C. I hope you have understand it. Now, similarly, you will prove for intersection. All those symbol for intersection will be replaced by here AND. The symbol is just like this. This will intersection will be replaced by this, and the proof will be there. You will do it. You can do it. Now let us do distributive law. Now I will prove it in the case of the second case. We will prove now A intersection B union C equals A union B sorry, A intersection B union A intersection C. Actually, if you if all the union are in this set are replaced by intersection and all the intersection are replaced by union, then actually you will get this. If this union replaced by intersection and this intersection replaced by union, you will get this set, right? So it's a duality. Actually it's a duality. While union and intersection interchange, then we can have the both of the relation. Now let us try to prove this one. The method is similar. Again, we consider element X from A intersection B union C, which implies X belongs to A. It is intersection, so means and X belongs to B union C. X belongs to A and X belongs to B, or X belongs to C. Now X belongs to A and X belongs to B. Here will be a first bracket. I will justify later why I am doing this. This symbol will come here. X belongs to A, and this will come again. X belongs to A and X belongs to C. Now see, you write X belongs to A and X is also and X belongs to B union C, right? Now you write from here X belongs to A and X belongs to B. Since X belongs to A, X belongs to the set A, right? And X here X belongs to either set B or set C. Here is the intersection, so here both the element X must be here C and from B. Both the set B and C must contain the element X, so I have taken X belongs to A and also X also belongs to B. So we out X belongs to here, and we have to return the operation of set in which is intersection here, or X belongs to A intersection C. Now take out the X belongs to, we are left with A intersection B union A intersection C. This is the one part. Again, Y belongs to A intersection B union A intersection C. Firstly, here is union. Y belongs to A intersection B, or Y belongs to A intersection C. Now Y belongs to A intersection, intersection will be replaced by and Y belongs to B, or Y belongs to A and Y belongs to C. Now we take out Y belongs to A and we are left with Y belongs to B or Y belongs to C. Y belongs to A and take out Y belongs to, left with B union C. Take out the whole Y belongs to, we are left with A intersection B union C. It's not one, sorry. So X belongs to this set actually implies X belongs to this set, so we can write A union B union, A intersection B union C subset of A intersection B union A intersection C. It's 1. Now here also we can write A intersection B union A intersection C subset of A intersection B union C. It's 2. Now from 1 and 2, by the definition of equality of two sets, we can also say that this result is also true. So actually we proved both this laws of set algebra, right? Now I will do the proof of De Morgan law. Now this is different from the proof of associative law and distributive law. You will understand. Now let us prove the first one or the second one, randomly chosen. Okay, first one. Or the second one. Okay, let me prove the first one, please. So here, in associative law and distributive law, there were no complement. So here the problem is complement. So let us proceed the initial method. Let us consider an element X which belongs to A union B and its complement. If I draw a diagram of Venn diagram, it's A, it's B. The total shaded portion denotes A union B, which we know. And the other part, all the white part of the portion denotes A union B, its complement, as A union B complement equals to universal set minus the set itself. So these white areas actually denotes A union B, its complement. So let us take an element X. X is here, and we are actually taking X from A union B, its complement, right? The white portion here. So if X belongs to A union B, its complement, so X does not belongs to A union B. X is here. X is nowhere inside A or B, right? Okay. So X does not belongs to A. Now that's an interesting part, and also a section where maximum student will do the mistake. And X does not belongs to B. In associative law, distributive law, we have replaced union symbol by OR, right? But here simply you can see X belongs to A union B complement. So X is neither in A nor in B. So how can I write here OR? We have to write AND, right? We have to write AND, as X neither belongs to A nor belongs to B. So if X does not belongs to A, so where is A? A complement. If does not X belongs to here, so outside A, X lies, right? And X belongs to B complement. Okay. A dash actually denotes complement too, so it's not a big factor. X belongs to A complement. This symbol will actually return the operation of the set. So we come to this relation. So we can say A union B, its complement, subset of A complement intersection B complement 1. Okay. Now let us consider another element Y which belongs to A complement intersection B complement. Now Y belongs to A complement. Intersection B complement. Here similar way we have to change it into OR. Y belongs to B complement, right? Either Y belongs to A complement or Y belongs to B complement, but we can't say AND. Okay, either A complement or B complement. So if Y belongs to A complement, so Y does not belongs to A. Y does not belongs to B. So Y does not belongs to A union B. If Y does not belongs to A union B, so where does Y lie? A union B, its complement. Oh, I have given it C here, so let's give it C. C, okay. Give it C. Okay, no problem. C. Give it back to C. everything is C here. So we can say A complement intersection B complement subset of A union B, its complement from 1 and 2. By the definition of equality of two sets, we can write A union B its complement equals to A complement intersection B complement. In the same way, we can prove this, right? And I hope you have understand the method of proof, how to prove the laws of set of algebra. Thank you for watching the video. If you enjoyed it, don't forget to thumbs up and also subscribe for new videos. For any queries, comment below. Thank you.